Hello dear friends, welcome to another video of the Never Do Through the GUI what you can do through the CLI channel. I am Vangelis and today we will be exploring Web API benchmarking, C++ Drogon vs Rust Actix-web vs Rust Tide. So today we will use the big guns. As you can see, we will benchmark the Drogon framework, and we will check how it performs compared to Rust, and we will get a little surprise. I hope that the results will verify what I'm saying now. We will have a surprise in our results, and we will talk about it towards the end of the video. So if you don't know the Drogon framework, according to the benchmarks here, to the techaempower.com benchmarks, the Drogon is the fastest framework. Drogon core here, as you can see, and here is the Drogon itself. We have Drogon core and Actix core, but I am not sure how they are separated and how they perform the benchmarks on the core, let's say, framework, and what's the difference with the actual framework. But in any case, we will be benching the Drogon framework, and we will see what we will get. Let me show you the code before we begin. This is the Drogon application. We use 16 threads. This is the number of threads that gave me the best results between the logical CPU cores, which is 16, and the physical CPU cores, which is 8. So I am going with the 16 threads, and this is the actual code. We hit this endpoint and we get this JSON value back, and we will only be getting one user because I did not manage to return an array of users no matter what I tried. So I will not spend any more time trying to return an array of users. We will go with this single user. So if we check the APIs in the browser, this is our Drogon API currently working, and this is our Actix-web API, and this is our Tide API. So I modified everything in order for us to get only one user. So this was the introduction, and now we will get into the actual benchmarks. Let me reset this. I was testing what was better between the threads. So yeah, another point that I want to make is that I have built the Drogon framework in release mode. If you check the documentation, there is something while you build that you have to provide if you want the release mode. And this is how we build and run the application. We cmake the directory above and make, and then we run the binary. So let me rerun. Let's check here that we still have it. Okay, and we are ready to start benching. So the first thing that we will do is we will bench the Drogon 4 with the OHA command, and we will use this number of requests. Yeah, I'm using the OHA because Tide does not work well with the Apache bench, so I will use OHA for everything, and we will be monitoring, of course, our system here, and we will be storing the results of everything. So let's start here, and let's see how it goes. CPU 37 40 69 40 69 41 231. So let's put it down here. 41 231 41 231, and let's get the results here. Copy. Okay. So let's go for Actix-web now. Let's get the command. This is the command for you that you are interested. So copy, let's come here and let's check. So 2112 then is the result. 2112, and let's get the actual results. Copy. Yeah. Next in line is Rust Tide. So bench, and let's come here. (26.6.5). 26.6.5, 25.6.5, 25.6.5, 25.6.5 megabytes, and let's get the results. Copy. Okay, let's start comparing now. Success rate, everything was successful. Total 12.5 seconds. Total 12.1 seconds. So, and total 14 seconds. So here it seems that Rust performed better with Actix-web, and also Actix-web performed better than Tide, which is a surprise. The surprise that I talked about, we will see more of it as we bench with WRK also. So slowest 0.8, slowest 0.255, 0.873, 0.770. So again, Actix-web is performing better than Rust, than Tide, and than Drogon. Let me zoom in a little bit more. Slowest is fastest. Fastest 0.1, 0.001, the same for everything. Okay. Average 0.013, 0.012, 0.015. So yeah, Actix-web and Rust outperformed Drogon and Tide. Total data, it also gave us more data. So more data in less time, that's good. Size per request, yeah. Size per second, okay. Let's check the response times. Yeah, the majority of the requests needed this amount of time, which is quite good, as you see. The Drogon also has a very good response time. This diagram is quite good for Drogon and for Tide, so the differences are not huge in the diagram. Let's check the latency. Latency. %, needed this amount of time, so Drogon is here better. Yeah, then Tide, then Actix-web. 25 needed this amount of time. Drogon is better. 50% needed this amount of time. which is the same. So for this amount of time, the same amount of requests were executed. This is worse. 15 here. Actix-web starting to get better. So for this amount of time, it executed more requests. So in less time, it executed more requests. Here also, Actix-web is better from all the other stuff. Here, Actix-web is better. 99, yeah, and here, Actix-web is better. No, here, Tide is better. The 99% of the requests were executed in this amount of time. So here, Tide is better. But overall, Actix-web is performing better. The DNS we don't care about, status code distribution, so everything we have total success for all frameworks. So as you can see, the first point is that Actix-web seems to outperform the Drogon framework, which is quite good, and I don't know if I can say that it is impressive. I was expecting Drogon to be faster, but it seems that Actix-web is faster, but I wouldn't say that it is a surprise because we know that Rust provides comparable speed to C and C++, so it's not a surprise, but it is a very good point. And the other part of the surprise is that we see that Actix-web is outperforming Tide and async-std when we switch from 1000 users to 1 user, which is impressive to me because I would expect, due to analogy, that since we are faster with Tide for the 1000 users, we would be faster for the 1 user, so it would be analogous, but it seems that it is not. We will verify it in the WRK benchmark and then we will draw our final conclusions. So do I have all the stuff here? Yes, okay. Let's proceed to the WRK. So we will come here. We will bench for 30 seconds. Start benching for 30 seconds and let's see how it goes. 60 CPU, 61, 672. 60672, 61672. The memory is stable at 672. (672) and 61. 672 and 61 utilization, and let's get the results. Copy. Okay, let's go to Actix-web. Here we are. 52 memory 21. You see that we have a huge difference in the memory required for the test. A huge difference in memory because Rust auto freeze the resources. So 5321, let's say. I missed the actual CPU, so 21 here. I saw something about 50. I think 53 was the best utilization we got. So let's get the results. Copy. You see the difference in the memory, which is astonishing. Very astonishing. And as I said, I suppose because Rust auto-frees the resources, we managed to have so low memory consumption. Okay, let's go for tide. Copy. Let's prepare this. Okay. Bench. Let's see here what happens. 27, 36, 45, 37, 40, 47, 36, 47, 35, 47, 36, 48, 36 is the major one, 48, 36. I think 48, 36 will be our numbers. 48, 36. 48, 36, and let's get our results. Copy. These results will be available in the description of the video, so you can recheck them, of course. And let's start comparing now. Latency 613. Something else I just noticed is, as you can see, we have errors for the Drogon API for this benchmark. So this is something to keep in mind, whereas we have no errors for the other two for the Rust frameworks. So latency 613, latency 1.25 millis. This is US though, not USA, but I don't know how it is called in English, but this must be a smaller unit than milliseconds. So it seems that Drogon is better. Max here, yes. So Drogon is better for the latency. Request per second 104.63K. Request per second 139.58K. So Rust Actix-web is outperforming for this metric. For the max, Drogon is a little better, but the average, as you can see, Rust Actix-web outperforms the Drogon C++ framework. Number of requests, we have 3 here, we have 3 here, so we have 25 million. And how many do we have here? 3, so 18 million here, 18.5 and 25 million. So we have a substantial difference here too, as you can see. And this is also reflected in the requests per second. So we have 623,000 here per second, and we have 831,000 here for Actix-web. So yeah, it is official, Actix-web outperformed Drogon in both the OHA benchmark and the WRK benchmark. Plus the Drogon API gave us some errors here, whereas Rust did not give us any errors. Transfer per second, also here Actix-web is better, as you can see. Cool. And let's check now the two Rust APIs. Latency, Actix-web is better for the average and the max. Requests, also Actix-web is better, which is treading in the same lane of surprise. Max also better. So here what we have 3 and 3, and we have 9 million requests, whereas here we have 25 million. Also the difference here, we have 300,000 per second, and here we have 831,000 per second. Transfer also huge difference. So as you can see, Actix-web outperforms both the Drogon framework and the Tide framework, async-std Tide. So the overall result is that it seems that Rust outperforms for this benchmark C++. So I am not sure what the setup for these benchmarks are, but as you can see, at least for the benchmarks that we executed, we see that Rust outperformed C++ and Drogon. This is point one. And the second point, to expand on it, is that we see that Actix-web outperforms async-std Tide for this specific benchmark, for the one user that we get, as you can see. So what should we get as a conclusion after we saw this? Why does async-std Tide outperform Actix-web for the 1000 users, and why the opposite happens for the one user? I don't know that I can provide I don't think I can provide an answer. I cannot think why that should happen. Why the framework or the loop, let's say, because I think that we come down to the actual loop. I can't provide an answer, to tell you the truth. I don't know if it is related to the threads and how the load is handled from the threads and the runtime, or we have a different difference in another point of the code execution. I don't know how we should go about identifying this difference. I don't know, with a flame graph maybe. Would that be something that would show us why this difference exists? I don't know. I will be waiting for your feedback in case you have something to contribute for us to gain more knowledge. You can always comment, of course, and we can talk directly if you want. You can find my stuff on the internet. So yeah, in essence, this was all the information. I wanted to check this benchmark with C++ and Drogon. I had it in my mind for quite some time now, and I finally managed to do it today. So yeah, I hope it is useful to you in the future, and yeah, whatever. Have a nice day, and see you to the next video. Bye.